One of the things we want kids to understand about angles is that an angle is not actually something that's just sitting still. An angle is the movement between two sides that make the angle. So if we look here, this opening is making the angle bigger because we're talking about what's inside of these two lengths here. And so when we talk about moving an angle or making it bigger or smaller, we're going to open it up. And so if you look, this angle right here is an acute angle. And then if we open it up farther and go straight up and down, we've got a right angle. And then if we open it up even farther, we've got ourselves an obtuse angle. But ultimately, for an angle, what we're talking about is this distance from here to here. It's not a straight distance, it's an angular distance. And we're talking about the opening between the two sides that meet together. And this point right here, right there, is called our vertex. So you'll hear us talking about the vertex. But again, we're trying to get the kids to understand that an angle is this opening of the two sides. And the bigger the opening, the bigger the angle. Okay, so then we are talking about the different types of angles. We have a right angle. Now, a right angle are those perpendicular that we talked about before. They make a 90-degree angle when you put the two sides together. And a lot of times we use this little box to show a right angle, and that's something they need to become familiar with. If you see the box, that means it is 90 degrees. Okay, if you see the word acute, acute means, if you think of a right angle being right there, an acute angle is going to be smaller than that. It's going to be on the inside of that, so that this distance right here is less than 90 degrees. So we would look at an acute angle as being smaller than 90 degrees. And an obtuse angle, once again, if we look at the 90-degree angle here, an obtuse angle is going to be outside of that, and so that this angle here is more than 90 degrees. And the reason that we do that, and a lot of times I know that's one of the questions parents have, is why are we doing this? One of the things we do is later on, sorry, I'm ahead of myself, but anyway. So why do we do this? So what happens is later on, we're using protractors, and knowing whether something's bigger than 90 degrees, less than 90 degrees, and so on, knowing that actually helps them use the protractor properly. And these are words that we're going to use quite often. So it's a good idea to really get a handle on these words. This unit or this section is actually really big on vocabulary. So that's pretty much all we're doing today in this, is talking about vocabulary. So then we go on to triangles once we've got our angles figured out. Now a triangle, you have three different ones here that we're going to look at, and these are when you're looking at a triangle based on its angles. So if you're classifying it, giving it a name based on its angles, we use these words. So you have a right triangle. That's a triangle that has one right angle, and then the other two are not right angles. Okay, we have an acute triangle. That means that all three of the angles are acute. I didn't do a very good job. That looks more like a right triangle. But all three are acute. Oh, I'm horrible at drawing acute triangles, sorry. Okay, I can do better. Okay, so there's an acute triangle. And then we have the obtuse triangle. That's where one of the angles is bigger than 90 degrees. The other two then happen to be acute, but we've got this angle right here that's bigger than 90 degrees. Okay, so those are your three types of triangles based on the angles that they have. We can also look at a triangle and base it on the sides. So you have a scalene triangle, means that none of the sides are the same length. So that's scalene. They all have different lengths. When you have an isosceles triangle, that means two of the sides are the exact same length and the other one is not. And this is probably too early to talk about it in their level, but on the high school level, one of the things we do is we put little lines on the triangle to denote that they're actually the same size, the same measure, and that's why I did that. But it's basically saying that this side and this side are both the same length, and so then it's isosceles. An equilateral triangle means that all three sides are the exact same length, and that would be an equilateral triangle. So that's if you're basing it on how the sides are all measured out. Another vocabulary is other polygons. Now these are bigger polygons, so they have 4 or 5 sides, but the word convex and concave. Now convex means that when we look inside the area of this polygon, okay, that all of these vertices, all of these are sticking out, okay? They're all sticking out. But when you have concave, when you're looking inside, we have one vertice that comes into the polygon. And so that makes it concave. So we've got this area that caves into the polygon, and that's why it's concave. So the idea is, one of the rules they say is, if you go from one corner to the other corner and you ever travel outside of the polygon, then it's concave. See, when we're in convex, every time I go from corner to corner, I'm always inside the polygon. There's no way that I'm going to go from any corner to any other corner and be outside like I was here. And so that's why this one's concave. So this one's concave and this one's convex. And the last thing for our video is talking about activity you can do at home with your kids when you're talking about these different angles. So, when we look around at buildings, they have different kind of roof lines. So if you look at the school is flat across, right? So that's at a 180-degree angle. When you look at some houses have a really steep pitch. And so if we look at that second house there, we have this less than 90-degree angle. We would call this an acute. So, and then when you look at some other houses, they have a really wide pitch. And so then we're talking about that being obtuse. And so, just even when you're driving in the car and you see houses, just talking about what kind of roof line do they have? Are they acute? Are they obtuse? Are they 180 degrees? What are they? And just kind of settles in more of that language and how we use that.